Okay, Assalamualaikum. To all my students, MEC351. Okay, so now we are going to learn about chapter 3, air conditioning system and equipment. So for now, we have already learned about the chapter 1 and chapter 2, the refrigeration cycle, and also air conditioning processes. Okay, so for the chapter 3, this is more on the applications, systems and equipment. So basically the chapter 3 is more on the theoretical and information based, uh, not a calculation based chapter. Okay, so first, from this slide, uh, before you consider a type of air conditioning system that have to be chosen for a building, there are some variables or factors that you have to consider, such as load changes. This one is cooling load. Okay, this is basically the cooling load. uh, Normally we use in the BTU per hour unit, or sometimes also kilowatt, or sometimes refrigerant tons. Okay, this is for the cooling load changes here. Okay, the second one is the zoning requirement. Some of the spaces in a building, some spaces need certain requirements, such as if you are in a hotel room, the requirement will be different compared to the classroom or also the shopping complex. So as an engineer, before we design our aircon system, so we need to know the zoning requirement. Okay, the third one is the space availability, because if certain space or requirement of the space don't have enough space availability for our system, so we have to find the alternative system. Okay, let's say uh, we have a small room. If you want to put a large what we call package unit, so it is not suitable because of there is no space for you to put your aircon system. Okay, so it also one of the factor that you have to consider. And finally, we also have to consider the cost. Yes, as an engineer, the cost is one of the constraints that you have to face for every time you have to make a decision. Okay, so the equipment can be selected after determining the cooling load. That's what I have mentioned earlier, cooling load. One of the first thing that you have to come into your mind before you choose the aircon system. Okay, the equipment can be selected after determining the cooling load estimation and the other necessary data. Okay, studying of manufacturer's product technical data would must be of great help. Okay, so let's say if you want to design an aircon, so you must be familiar with a certain brand or common widely use of the aircon manufacturers in the world. Then you have to familiar with their products. Okay, let's say this is one of the most known aircon manufacturer in the world, Carrier. And maybe you also have heard about Daikin. Okay, what else? Your and so on lah. Okay, so After you have a cooling load value, so you have to choose what type of aircon system that you are going to use, and finally you have to know uh, which type of the model for the certain brand that you want to choose. Okay, let's say we have a cooling load of 100,000 BTU, but here we don't have the units in BTU, so you have to convert the BTU per hour into the kilowatts, or also refrigerant tons here. So then you have to choose the model that is in between the range that the model is capable to supply the cooling power. Okay, so this is one of the scope in your mini project for this semester or for this subject. You have to design an aircon system in a building that you have that you will choose, let's say a house. So then you have to calculate cooling load for that house, and finally you have to choose the aircon based on the catalogs of air conditioner manufacturers in the internet like this. Okay, okay, hello, okay, okay. So now we go to the classifications of the aircon system. Okay, one type of the aircon system is what we call unitary or central system. Okay, unitary system, or sometimes we call the package equipment here. Some system components, fans, coil, refrigeration equipment are furnished as an assembled package like this. The cool air is thrown by the high capacity blower, and it flows through the duct lead through various rooms, able to cool more than 2 rooms or larger space at your home or office. Okay, and the other type of central system, also we have what we call a centralized system or chiller. Okay, the components are furnished separately and assembled by the contractor. Central air conditioning system is used for cooling big building, houses, office, entire hotels, gym, movie theaters, factories, and also in our UITM in Penang. Okay. In the central air conditioning system, there is a plant room where large compressor, condenser, expansion valve, and the evaporator are kept in the large plant room. Okay, sometimes we call this a centralized aircon system here. We call the chiller system, because we have a separate or specific plant room where for the UITM it is located around the BKBA. Okay, under the ground floor at BKBA, and then in that plant room you have the compressor, condenser, expansion valve, and the evaporator there. And from there, it will be connected with the cooling tower to remove air to the surrounding, and also it is connected to the a large numbers of AHU in the building of UITM. So let's say in our FKM building, we have at third floor alone we have around 5 to 6 AHU room. AHU stands for air handling unit. Okay, we will go deeper about that after this. Okay, so basically for the unitary or central system, the first one we have the package, and the other one we also have the chiller, the separate system. Okay, the cooling medium that is used, there are 3 possible groups in regard to the medium used. Okay, some of the system will be categorized based on the medium of the cooling. Okay, the first one is if we use air to cool the condenser, to cool the evaporator, then we call it all air system. if you use the water to cool down the evaporator, so that we call the all water system. And finally, there are also some of the system that combine both methods, so we call that combined system. Okay, don't worry, we are going to go more details about this after this. Okay, so the zoning system here, sometimes we use the single zone or multiple zone system. Okay, single zone system is air conditioning only on one zone in a building. A group of rooms be maintained by a single controlling devices. Example of AHU, air handling units, and also FCU, fan coil unit. Okay, let's say if for our house, if we use the package unit, so we only use one AHU to control all the system, because we do not have a specific requirement for every room in our house. So that's what we call the single zone. But for the multiple zone system, you have to satisfy a certain of air condition, where it is a specific condition for every room, and then you have to utilize the multiple zone system. Okay, let's say in hospital, example of in the hospital, we have ward, okay, ordinary ward. Then we also have the operation room, or what we call the operation theater. The condition of the air in the operation theater is very critical. You have to get the precise and accurate condition, like the temperature and also the humidity must be accurate to prevent any bacteria growth in that room. Okay, but for the ordinary ward, the conditions requirement is just similar to the hotel or our bedroom. So that's what we call multiple zone system. Okay, so this is the chart to make you understand about the categorization of the aircon system. The first, we divide into two types, direct and indirect, and then depends on the cooling medium. If you use the air cool, so we will call the air cool and also the water cool, because the split type here, split unit system, is the common aircon types that we use in the residential house, like our house lah, like our home. Okay, and then we also have the single package that can be put on the floor, also on the roof. Okay, and both of them can use either air or water cool system. Okay, so split type also have a pair system, where we call split pair system. This is the common that we found in the house, where we have one indoor unit and one outdoor unit. Okay, so for the multi-system, it will cool the multiple room, compared to the pair system. Here only can cool one room per one device. Okay, for the multiple system, if we have the limited space, then we have to use the multi-system. So where the outdoor units, the outdoor unit is only one, but it can be connected to multiple numbers of indoor unit. Okay, so for the pair system, we have one outdoor and one indoor. Okay, here. Ow. And here for the multi-system, we have one outdoor and two or more indoor unit. Okay. Okay, so for the indoor unit, it can be in the form of wall mounted. Kita pasang dekat dinding yang macam biasa tu. Either ceiling mounted, ni kita letak kat ceiling. Ni macam biasa jumpa kat kedai. Okay, and also the floor mounted. Ni kat lantai lah. Okay, untuk multiple system pun sama juga. Indoor ada bentuk yang sama. Dia boleh pakai benda yang sama. Cumanya outdoor dia ni lagi besar compare dengan pair system sini. Split unit pair system. Okay. And for the package, yang ni depends on the requirement of the room. Basically, the single package will be used in the higher cooling load requirement. Okay, but in the limited space, because if we have a very large space for our aircon system, so it is better if we use the indirect expansion. Indirect expansion ni yang tadilah yang chiller ataupun yang package juga, yang package besar juga. Okay. So ni yang biasa dekat indoor unit. The normal forms of the indoor units. Okay, wall mounted. This is the very common indoor unit that we found in our house. Okay, below ceiling mounted, this is still on the floor but just below the ceiling, and this is the ceiling cassette. Okay, and then this is the floor standing, and this one is the FCU, fan coil unit. Fan coil unit normally is used in hotel room because the fan coil unit can be used in a limited height of the ceiling. Okay, so we go back to the types of the aircon system. Here we have the direct expansion and also indirect expansion. Okay, apa beza? What is the difference between the direct and indirect? Okay, kalau direct, we directly remove heat from the refrigerated space here using our refrigerant here. Okay, yes, we have learned in the chapter 1, we have 4 basics components in refrigeration, and that 4 basics also is the basic components for the air conditioning system. Okay, so here the refrigeration cycle in the direct expansion aircon is directly used to remove heat from the refrigerated space to the outside. So here we have the evaporator, and here we have the condenser. Here and here we have the expansion valve and the compressor. Okay, jadi dalam ni, in the copper pipe here, we have the refrigerant. So the refrigerant will absorb heat and remove heat to the air. So dia direct, dia terus ambil, dia terus buang, dia ambil, buang. So that's what we call the direct expansion. Okay, okay, for the indirect, tapi indirect dulu terang. Dekat sini, absorb heat from the refrigerated space yang kita nak sejukkan, tapi sini kita tak pakai, we don't use the refrigerant here, we use the chill water. Okay, okay, daripada chill water sini so sini akan ada AHU, air handling unit, and maybe FCU, fan coil unit. So chill water will absorb heat from the refrigerated space, and it will go to the chiller here. So kalau let's say FKM buildings, in our classroom in FKM buildings, the chill water will absorb heat from the AHU in our class, and it will transfer heat from the AHU air handling unit to the chiller that is located at BKBA. Jauh kan? Okay, and then the heat will be transferred to the refrigeration cycle in the chiller, because the refrigeration cycles occur in the chiller. So basically, a chiller will have four basic components, which are compressor, expansion valve, evaporator, and here the condenser. So if you have the condenser here, so the chiller will remove heat to the surrounding. Okay, here to remove heat to the surroundings, we have two methods. Okay, the first one we call the air cool, and the second one we call the water cool. So the expansion of the system here is not direct, so that's why we call the indirect, because we have another medium here, the chill water and pump to bring the heat from the AHU to the chiller, and then from the chiller it will remove heat to the surrounding using air if it is air cool, or using cooling tower if you use the water. Okay, so here this is more details, you can read by your own. Okay, this one, the pictures here shows the advantages of the chiller. One of the advantage that chiller have compared to the direct expansion, because here if you use the direct expansion for every room in this building, so we will have a lot of the split unit system, and then it will affect your facade building, make it more uglier. Okay, kalau architect tahu ni marah lah kan. The architect design a building so beauty, and then you as an engineer jeopardize its beauty by putting more the aircon system on the wall here. Okay, so this is one of the diagram of the chiller. Okay, here we have FCU, and then we have AHU. Okay, so AHU and FCU is used to supply cool air to the refrigerated space, and then the heat from the refrigerated space here will be absorbed into the air, and then will be absorbed by the AHU. The energy or heat that is absorbed by the AHU will be passed through to the chill water return here. Okay, if you found the blue pipe in the ceiling around our FCAM building or any shopping complex or any building that you find, it will have a certain symbol CHWR and also CHWS. Okay, because CH means for the chiller, W means the water, R means for the return, and S here means for the supply. Okay, so the water will return to the AHU and will supply to the chiller, and the loop will be goes on until you shut down all the AHU and also the pump. Okay, so here in the room we will have a conditioned air, a thermal comfort air, and the heat will be processed by the chiller, and then will be removed to the surrounding, either using the direct air cool, or we will use the cooling tower if it is using the water cooling method. Okay, so we go back to the direct expansion. There are many types here. We have single package. Okay, this one is a larger single package where will be located on the ground or maybe on the flat roof top, and sometimes for during 80s, during 1980s and 1970s, most of the aircon in our house are using the single package that will be put on the window, your window. And then this one is the rooftop package. Okay, you see here there are difference in the range of the BTU power. Okay, let's say single package can be used if you have the cooling tower, cooling load around 90,000 to 24,000. Okay, but if you want to go more larger, you have to cool down a larger room where the cooling load is between the 80,000 and 200,000. So the rooftop package is more suitable. Okay, and this one is the split type. This is the normal types and the simple types that we use in our house. Okay, the capacity can be used for the 9,000 until 60,000 BTU per hour. And for the multi-system that I have explained before, similar to the split type here, pair system, but from by using just one outdoor unit, you can be used for the multiple room. Okay, so normally the outdoor unit is very large to cater a multiple indoor units here. So the range can be from the 90,000 to 38,000 BTU per hour. Okay, so here it says that it is more economical. Okay, the economical here means that for the long run it can be cheaper, because if you have 4 rooms, you have to buy 4 pair system, but for the multi system you can use maybe just 1 or 2 device. You have just to buy 1 or 2 system. But for the maintenance cost, maybe the multi system is more pricier or more expensive. So that's why you have to study first or research first before you make a decision to choose the type of aircon. Okay, so also we have the package type here that is using the water cool type, and the split type here using the water cool. Okay, in some conditions that the outdoor unit is very far from the refrigerated space, they can use the water cool. Okay, compared to the similar here split types, because we just use the copper tube here. Maybe here is no more than 15 feet or no more than 5 meters. But if the distance there is very far between the condenser and the indoor unit, so possibly the split type of the water cool is better. Okay, so here we go to the types of the chiller. Okay, chiller also have the air cool and also have the water cool. Okay, if the chiller use the water cool here, so it will be connected with the cooling tower like this. Okay, so which one is the better depends on your applications requirements. If you just need a lower value of the cooling load, okay, cooling requirements, so the air cool could be better. But if you have to cool down a very large space of the area, and then a very high the cooling load value, so the water cool chiller is better and suitable. Okay, so that's why you have to get the value of cooling load first, and then after that you decide which system is suitable for your designs compared based on the criteria that I have mentioned in the first slide here. Okay. So if you choose the chiller water, then you must use the cooling tower. Okay, so we have, okay, now in this slide shows the chiller system in UiTM, UiTM Pasir Gudang here. Okay, so this one is a compressor, evaporator, throttling valve, and condenser. So you see here we have two colors of pipes, blue pipe and yellow pipes. Okay, yellow pipes will be connected to the cooling tower, and the blue pipes will be connected to the air handling unit, AHU, and also FCU, fan coil unit. Okay, this one is the AHU, air handling unit. Okay. Okay, this one is the cooling tower that is used in the UiTM Pasir Gudang. Okay, I took this picture during my tenure in UiTM Pasir Gudang. Okay. In the cooling tower, there will be the reservoir at the bottom of the cooling tower, reservoir of the water here. Okay. Here is the diagram of the chill water system. Okay, this one is air handling unit. Okay, and then the water will be returned back to the chiller, where the chiller we have the four basic components: evaporator to absorb heat, and the compressor. This one we call a motor. Motor will be connected to the compressor and compress the refrigerant into the condenser. Okay, condenser here will transfer heat to the water from the cooling tower, and then the water will go to the cooling tower with higher temperature because it absorbs heat from the chiller, right? Okay, so when it comes to the cooling tower here, the temperature, the water will transfer heat to the air surrounding air. Okay, that's why the water will drops from up here to the bottom where we find this water reservoir, and the air will pass through along the water droplets. So the air that comes in from here is the surrounding temperature, and after it gets the heat, absorb heat from the water droplets, and then it will exit the cooling tower with higher temperature because of the heat absorptions. Okay, so that's how the heat is removed to the surrounding using the cooling tower. Okay, so for the cooling tower, we have two types of the mechanism. First one is called, okay, mechanical cross flow. This one is the cross flow. Okay, water from up and here from the outside, similar to the similar directions. So that's what we call the cross flow. If the counter flow, it will go with opposite direction of the water flow. Okay, so you can read by your own, or you can find the videos detailed videos about the cooling tower in the YouTube. There are a lot of videos I found in the YouTube. Okay, so this one is the mechanical draft because we use the mechanical equipment up there, the impeller that is connected to the motor to drive the airflow. But we also have the natural draft here. Okay, this one is the natural draft cooling tower. Okay, this is the cooling tower that you will normally found in the nuclear power plant, the coal power plant, or gas power plants that is located far away from the water resources such as the river and sea. Let's say we have a power plant in the desert, so to remove heat to the surrounding, we cannot use the mechanical draft using the water, right? Because we do not have the water resources. So that's why we use the natural draft here. Okay, natural draft, there are very high of cooling tower here. Okay, so more higher, so it will get a higher pressure difference, and from the pressure difference it will make the air goes from the below and then draft back to the surrounding by going upwards. So during it goes upwards, it will absorb heat from the water droplets here. Okay. Okay, so the general equation of the cooling tower, similar to our air conditioning process that I have discussed before. We use the dry air mass balance, water mass balance, and also the energy balance. If you see the difference between our air conditioning process before, we have another energy of the fan here. Okay, so I think that's all for the chapter 3. Okay, chapter 3 is more on the theoretical about the air conditioning system and equipments. Okay, so after this, in the next week, we are going to have the test 1. Okay, after that, we are going to the chapter 4, which is the cooling load calculations. I will teach you how to calculate the cooling load, and after that we have the final chapter, chapter 5, that we are going to learn how to design air ducting system. Okay, air ducting system, that is the normal system in AHU, air handling unit. Okay, so that's all for today. If you have any problems or any question, you can ask me in the WhatsApp group. I do not recommend you to personal message me if the question is regarding to the academics questions. Please ask me in the WhatsApp group, because by asking me in the WhatsApp group, I can answering you, and then it gives benefits to the all, not for the specific person. Okay, so once again, if you have any problem, please ask me in the WhatsApp group. Okay, so that's all. Thank you. Assalamualaikum and bye bye.